Well, hey everybody, let me share the screen. It'll probably help if you can see what I'm doing. There we go. Awesome. So, oh man, it's just a crummy weather, rainy Sunday morning, and I'm thinking about class tomorrow night. And what I want to do tomorrow is focus in on refactoring that the REST API code that came out of the box that I want to, let's refactor together the dictionary application into the beginnings of a phone bill application. I found this is a really effective way to get people, the students, like to understand the code and start thinking about things, and to make the project seem a little less daunting, because the concepts from the REST API and client server programming, it's likely all new to you, especially the Java stuff for the servlet API, all that kind of stuff. So, um, and in order to do that refactoring, like any good refactoring, you'll need to have tests for your code, right? We want to make sure that we can validate that the refactorings that we made work the way that we expect. And I guess that, this won't be refactoring in the truest sense of the code because we will be changing the semantics of the program. So it's not just to make the code easier to read. It's really, I guess, refactoring the dictionary application is something approaching a phone bill, but we will be using some of the same tools that we saw in the refactoring lectures in terms of renaming things, maybe moving things around, all that good stuff. And so then in order to, be confident in that refactoring, we'll need tests, both unit tests and integration tests, which the REST API program has, but they're a little different than the ones that we've seen before. And I'm thinking about class tomorrow night, and it's like, oh, we only have the usual, whatever it is, hour and 40 minutes. Um, and I want to make sure that we can focus on the refactoring. And so I thought I would spend a little bit of time put together the screencast to introduce the the testing apparatus for the project. Important pre-reading is the lectures about the foundations of the web, which hopefully you've already looked at, and especially testing with mock. So what are we talking about right now is, one thing I'm talking about right now is how the servlet can be tested using mock objects created through the Mockito API. I encourage you to review this screencast, or at least look over the notes, and maybe look at the Mockito website before diving too much into this. I'll talk about sort of the concepts, but the lecture will give you better specifics about the API and how to use it. And actually, I hear my voice is getting a little parched. I'm going to pause the recording, give myself a drink of water to have here. I'm not on camera because, I mean, I haven't done my hair. I look awful. Well, or at least I look even worse than I usually do. So I'll pause recording. I'll be right back. Okay. Well, hopefully I sound a little bit better. And if I get thirsty as I'm talking, I'll have some water right here. All right. So then let's dive into it. So let's take a look at Project 5 again, kind of remind ourselves because it's been a couple of weeks since we've looked at this. So, as you'll recall, actually, I just want to look at the picture. So for me, the picture is the thing that makes the most sense. There's two parts to this program. There's a client side and a server side. The client is a command line program that then invokes a REST API, so an HTTP-based way of accessing application logic. It invokes the client invokes that REST API, which is then implemented over on the server side in something called a, a Java servlet that runs inside a web container. And a couple of weeks ago, when we got an introduction to the project, we looked at the basic pieces, parts of what happens over on the server, and we used the debugger to step through the servlet. That lecture is, let's see here, back here from February 11th. Probably behooves you to take a look at that one also. Just again, to remind yourself of this. I don't, well, of course, I'll answer any questions that you have, but I want to make sure that tomorrow we spend our time together in class focusing on refactoring. So we've got this application. It's a distributed application, right? There are two processes that are talking to each other. Compared to your first four projects, there's a lot more moving parts here. And while everything is still pretty synchronous, I guess you can sort of say, hey, you run your client and then it hits the server, there is just a lot more going on here. And because of that, there's additional complexity, and there's even more of a reason to have automated tests for these things. You want to make sure that you not only understand what each of these components is meant to do, but then you can verify that each of the components is behaving in the way that you expect. And that way you can be more confident in the end-to-end functionality. So we talked a lot about the phone bill server, but just as a reminder, let's go take a look at it again. Oops, let's go take a look at it again. Okay, so here's the code, the phone bill servlet, and just recall that it resides in the phone bill web Maven project inside the source directory, the main Java. It's there in your package, and it's called phone bill servlet. And we talked about this a little bit, but just to reemphasize, so phone bill servlet extends the standard HTTP servlet class, which comes from the Jakarta API. So this is a standard Java API. As a matter of fact, it's pretty, well, this is an abstract class, right? HTTP servlet isn't actually the thing that's it's instantiated. Your servlet is, but the whole idea is that the servlet API provides the glue between your code and the web container through what's called web application. And all of this is covered in the Foundations of the Web lecture. So the phone bill servlet is an HTTP servlet and it inherits a number of methods that are all about responding to HTTP requests. And there is a method for every HTTP verb. So we talked about this last, earlier a couple weeks ago. There's a do get method, there is a do post method, and well, this implements the HTTP get and the HTTP post. And so, this is kind of a neat way to leverage a Java API, right? You've got an object that represents your servlet, and there are methods on that object that are invoked not directly by the user, but by the web container, right? It's the web container that ultimately translates an HTTP request to the Java code that fulfills that request. Now, along with the HTTP request, there's a lot of information. There's, the request itself. The request itself, has things like, oh, the URL that was requested and the MIME type of any encoded data. If there are parameters or if there's body to the HTTP request, again, all this stuff is in the lecture. All of that, you want that to be available to the servlet, to the methods that are operating on that request. And that is all captured here in an object and parameter to the method, something called HTTP request. And this is an interface. Okay, so there's this interface that has all sorts of information about, about the HTTP request. Similarly, there's an HTTP servlet response, which represents the response that is ultimately sent back to the client. That has, whatever data is data, the contents of the resource that's requested, information about how it's encoded, size of data, all that kind of stuff, cookies and things like that that might be set on the server side. And all of that is wrapped up in this interface. And as we saw when we were debugging through the code, we were stepping through things, you interact. The code interacts with the request and the response in order to, well, fulfill the request. So it gets information from the request, like, okay, the parameter, the values of various parameters sent to the request. And then it uses the response to send data back to the client via a print writer that's available from the response. So this is cool, right? And here again, I highlighted this last time. It's one of my favorite things about the servlet API is that they needed a concept of, oh yeah, hey, here's the text that is written back to the client, or here is the binary data that's written back to the client. They didn't invent some new interface for doing that. They just reused the APIs from Java.io, and so that makes it well, it's less code for the authors of the a Jakarta Servlet API library to have to provide, and it makes it much easier for those of us who are consuming the API, who are using the API, because it's something that's familiar. So this is the way a servlet works. It's got all of this, it got do post, do get, and this is where your application logic is, right? This is what this is how you're fulfilling a request, and this is important stuff, right? This is like what you're doing with your servlet code, and you want to be able to test this. However, this code runs in a unique environment. It runs inside a web application that's deployed inside a container. Um, and so then, you don't, the code that you write doesn't invoke do get directly, and your code doesn't create a servlet request and a server response. All of that is the responsibility of Jetty Jetty's a Java program, sure, and the Jetty authors are the ones that invoke the do-get method and create the objects that implement the servlet request and servlet response interfaces and send those objects to the do-get method that's invoked. But that's not your code. That's the responsibility of Jetty. And yet you consume those. And because you're programming to the interface, you don't really care what the implementation. I mean, some class must implement HTTP servlet request, and I suppose if we looked in the debugger, we can figure that out. But it really doesn't matter. All we know is that we've got some object that implements an HTTP servlet request and some object that implements an HTTP servlet response. And so we can, and because we believe that they implement those interfaces as expected, we can interact with them with confidently, knowing that they'll behave as we expect. So if I wanted to write a unit test for this code, because I don't, yeah, I suppose I could, and we'll see that with the integration test. Yes, you do run the servlet inside a container, but that takes several moments to start up, and you want your unit test to be really fast. So I want a true unit test, something that runs very quickly, something that is just targeted on this program unit on the do-get method. How would I do that? Well, what I would have to do now, I mean, I can write code that creates a phone bill servlet, right? It's just an object, it's just a class. You can instantiate it, and luckily the code that inherits from HTTP servlet doesn't require much of an environment, so you can instantiate it, no problems. But then in order to invoke its do-get method to make sure that the logic of do-get is what you expect, it has to, you have to provide it an HTTP servlet request and an HTTP servlet response. Now, you can look at these, interfaces, and just sort of scrolling through here. Yeah, there's a bunch of methods and okay, and oh gosh, there's all, actually there's a lot of methods. Look over here, the scroll bar, there's a lot of stuff here. Because I mean, it would be possible to like you write your own implementation of HTTP servlet requests that behaves the way that you want it to for that particular test. Let's say, hey, when I get the URL, which is slash calls or whatever, have it return all of the all the phone calls, or in this case, all the dictionary entries. But writing that implementation of HTTP server request yourself, that's a lot of work. It is having to write a lot of test code for this. You'd think there'd be an easier way, and there is. And but in either case, you don't want to send in a real implementation or like the same implementation of HTTP server requests that Jetty uses, because that probably comes with lots of dependencies on the context in which it's invoked, on perhaps the container. And again, the whole idea of a unit test is you don't want to spin up an entire web container in order to invoke a do-get method. So what you want to use instead is something called a mock object, which is an object that provides the interface of that you want. So it's an object that implements HTTP server requests, but maybe it doesn't need to implement all of it, right? So if all you're doing is interacting with the get parameter method, when you say request get parameter, as we saw, there were like a dozen, maybe 2 dozen methods in HTTP servlet requests. You don't want to have to implement all those methods. You only want to implement the things that matter for that test. And similarly, with HTTP servlet response, when it's interacted with, you want to be able to access the objects, access how it was interacted with to do things like get the content that was written back to the HTTP servlet response. So if the right all dictionaries method is invoked with the servlet response, you want to be able to get to, well, basically this data that's written to the print writer that comes from the response. Because if you could do that, then you could write a traditional unit test, right? Something that runs quickly, something that doesn't have much in the way of dependencies, but still validates the functionality of your code under test, which is your Java servlet. Well, luckily there's a way to do that using the Mockito library. And by do that, I mean create mock objects that you can then tell or configure to behave the way that you want. And then when you send them to your do get method, Your do get method doesn't know they're mock objects. It just treats them as HTTP servlet requests and HTTP servlet responses, interacts with them accordingly. And then what your test can do is validate that, yes, they were interacted with in the way that you expect. So let's take a look at that. So there is a unit test called HTTP servlet test. This is over in the source test Java, like all of your other unit tests were. And I'm just going to run it real quick just to make sure that everything does behave. And we'll walk through a couple of these. There goes, nice and fast, everything passed. Yeah, oh, there's only two tests there. That's cool. Let's walk through these two tests to see how the Mockito API is used to unit test servlets. So our first test is called initially servlet contains no dictionary entries. Okay. And so, how do you validate that? Well, what you're going to do is you're basically going to invoke the do get method with with no parameters because you want um, all of the entries in the dictionary returned. There won't be any dictionaries, and so then you'll in the case where there are no dictionary entries, nothing is ever written back to the client. It's empty. As a matter of fact, let's just see this in action using the real code, and I think that'll make it a little bit more clear what we're doing here. So let's see here. We're going to run we're going to run Maven Jetty run over here in the on the right because the right is what corresponds to the server. Okay, great. It's running on port 8080. And then we're going to go back to our web browser. We're going to open up a new tab and we're just going to ask for all of the calls in the phone bill. It's empty, right? Okay, so like just make sure everything's running. Yep, here we have the the default index.html, and when we list all dictionary entries and there isn't anything there yet, you get an empty text. So basically, what we want to do is write a unit test that says, well, when I have a brand new servlet instance, when I request all the phone calls, nothing is written back to the client. How do we do that? Well, that's what this test does. So ultimately, what we're going to do is we're going to create a servlet instance, and we're going to call the doGet method. But the big question is, what do we pass to the doGet method? Um, and then what do we pass to it, and then what do we validate afterwards? So let's talk about passing stuff to it first. Well, we need to have an instance of some object that implements the HTTP server request interface. Same thing with HTTP server response. The Mockito library uses this advanced feature of the Java language, the Java runtime of Java, called reflection to create like magical objects that that you can program to behave a certain way. And you know what? I don't need to go into a whole bunch of details of reflection and even the Mockito API. All there's a lecture for that. So let's just focus on the code. So in order to create these mock objects, the Mockito API has this method called mock. It's a static method that we are importing here. That you give it a Java class, and it returns a mock instance of that class. It's basically an object that implements that interface. But the Mockito API allows you to, I want to say, program, for lack of a better word, that object to behave the way that you want. So we're going to create a mock request and a mock response, and also a mock print writer and we'll see how that's used here shortly. So the whole idea is that we've got some, pretend, some synthetic, some mock objects that we're gonna work with that will behave just enough so that the test can do its thing. So the way that you program or configure whatever word they want to use these mock objects is by using this method from the Mockito API called when. That basically says, well, hey, when the get writer method is invoked on my mock response object, then return, well, my mock print writer. Now, this syntax is kind of wacky, and it takes people a while to get used to it, understandably, right? It's very different from the things that you've seen, because it's like you're invoking the method, but you're invoking the method for the purpose of configuring or training the mock object here. It's nice syntax. I mean, once you understand it, I feel it makes pretty good sense, but it's definitely different from what you're used to. So again, you use the when method to say, hey, listen, when the response.getWriter writer method is invoked, then return, and then return is also part of the Mockito API. This particular print writer instance. We'll see a couple more examples of this before we're done. And so now we've got all these mock objects. We've sort of wired, this print writer to be the response for, that print writer to be the writer associated with the response. And then we invoke doGet. We send our mock request and our mock response to the doGet method. And that will invoke doGet. And again, doGet, it doesn't care that this request object, this response object are mocks. It just interacts with them. And as long as the mock object behaves as it expects, doGet method and all of your application logic doesn't know the difference. It doesn't care because it's programming to the interface. Now back in the test, after we've invoked our method, right? This is our this is our method, our code under test. Then we need to verify that the mock objects were interacted with in the way that we expect. Now, what we expect here is two things. We expect that no data is written to the print writer, and that the HTTP servlet response we got a 200 back. Everything was okay. So how do we do that? Well, first we want to say that nothing's ever written to the print writer's response, meaning its print line method is never invoked. And so the way we do this is the following. Use the verify method. Now the verify method is a lot like an assertion. It basically says that, oh yeah, I'm going to verify that some method was or was not, in this case, invoked. And so it's verify that's invoked on a particular object. So, and actually, maybe the second example is a little better. We'll go back to that first one here. So we want to say here we want to verify that 200 was returned. So a 200 is HTTP 200 is okay. And so we want to say that yeah, the set status method was indeed invoked on the response with the value okay, with the value 200. And here again, this is syntax that you guys got used to from the Mockito API. So again, you say, hey, listen, I want to verify that this method, I want to verify this object was interacted with, and in particular, its set status method was invoked with a value of SCOK. And if wasn't the case, if set status was invoked with another value, or if it was invoked at all, then the verify would fail, the assertion would fail. Similarly, we want to verify that the print writers, the mock print writers, print line method was never invoked. And print line here, takes a string, and so you can say, hey, it was never invoked with any string. And again, you're making an assertion here. And if this wasn't true, so if it was invoked, if the print line method was invoked, then this verify would fail. Now, the first time people see this, it kind of blows their mind. Again, it's pretty different. I think if you start figuring out the pattern of what you're doing here, the unit testing makes sense. But but I do encourage you to study this, maybe go back and watch the lecture, try some things on your own, because being able to unit test your servlets is a very powerful thing, because that's where all your application logic is. I suppose you could factor your code in such a way that that you may not need to do this and still get the required test coverage. But the idea here is that I want you to use the Mockito API, and once you figure out how to do so, it really is a very powerful way to test your servlets. So again, I can run this test, and it runs just fine. Let's take a look at the second test. Now this one's a little bit more involved. This one, we test that one word can be added to the dictionary through the servlet. And so what we're going to do here is simulate the servlet being invoked with, the post method being invoked with two parameters. So we're going to create a dictionary entry for our old friends, doe, deer, female deer. And so then this is actually the real application, of course. And when we click submit, it creates it, which we'll see over here, right? It's posted doe, deer, female deer. And then it prints back this string defined doe as a deer, a female deer. And so we want to validate that functionality. We want to validate that yes, the servlet behaves in that certain way. So when a word and its definition are posted to the servlet, um, then the word is indeed added. And here again, this is just basic functionality. And you'll want to do something similar for your phone bill and your phone calls, and we'll start refactoring towards that in class tomorrow. Okay, so what do we need to be able to test adding one word to the dictionary via using the Mockito API? Well, first we're going to need some test data. So we're going to have a servlet instance, and notice that this is just creating a new servlet. No mock objects here yet, which is the nice thing about servlet API. You just create a new one, no problem. But we're also going to need some test data. So we're going to have a word and its definition, and so this is the word and definition that we're going to post. This is the word we want to define. And now we need to start creating the mock objects. So we're going to create a mock servlet request, a mock servlet response, and now we're going to do a little bit more with these mock objects. We need to simulate or we need to specify the behavior of an HTTP post. And so then, what's the behavior of an HTTP? Well, what's the behavior of a servlet request with an HTTP post? Well, the HTTP servlet request has the data that is posted to the URL. And so then, when for this particular test, when the get parameter method of the mock servlet request is invoked with the word parameter, so this is the word parameter, then what we want to do is return our test word. So this is the test data. So this is what we would have, put in here. So I guess I could just show you here. It's the same thing as saying what? Test word. So this is our word that we're adding here. Doesn't fit. Apologize. Um, Test definition. Right, that'll be this right here. So this is test word, test definition. And we click submit, there it is. Now something, and right there it is, in here in the server that's running. Now, something I want to point out is that this is a servlet that's running live in a web container. In our unit tests, we're not running a web container, right? This is just the code literally starts here. Well, JUnit calls this code in the add word one word dictionary method, and then we start here. We're not running inside a servlet or anything like that. So I can execute this unit test completely independently of any container that may be running or not running. And here again, this is a nice thing about the unit test. You want it to be able to run independently of its environment and not have a lot of environment that needs to be set up beforehand. So I'm using the Mockito API again, using this when method to say, hey, listen, when the get parameter method is called on the request with the parameter of the word name, I want to have it return the word test data. Similarly for definition. Right, because these are the things, and actually let's go back to the servlet here. Let's go to post. Right, this is the things that the servlet then calls get parameter on the request with this word parameter constant and this definition of parameter constant. So basically here I am, I'm configuring, I'm training my mock request object to behave the way that I want. As far as the servlet response, we're going to want to capture this text that is written to the HTTP servlet response. So now what we're going to do is we're going to we need to be able to have the print writer associated with the response um, capture what was written to it and then make it available to the test. Well, we can do that by having the print writer that is associated with the response be a print writer, which is a real print writer. Up above, we create a mock print writer, but now we're going to use a real print writer that is wrapped around something called a string writer, which is basically, well, a writer around a string in memory, a string buffer and string builder in memory. And so then we can do the following. Well, we can then get at this object. We've got this object here in the test, then we can interrogate this object to make sure that, yes, the text that was written is what we expect. Oops. So then, again, we create real objects here, and then we program our mock object to return this particular print writer. In the real world, when it was run with Jetty, Jetty would provide the print writer. But here, we use Mockito to have a test print writer that will give us the information we need. Finally, we have our code under test, which is servlet.doPost, and we send in the mock request and the mock response that have been configured appropriately. And now we make some assertions. So the first thing that we're going to do is we're going to verify that yes, this text was written to the print writer. And the way we do that is we then say, hey, what was that string that was written to, sorry, what was the text that was written to the string writer that had the print writer wrapped around it? Go get that and say, hey, it ought to contain the string, well, as, that's specified by this, which is defined, word as definition. So we should assert that first. So this is just a straight old Hamcrest assert, right? You've been using this for weeks now. There's no special Mockito code here, and actually that's an important lesson where you can have in your unit test a mix of Mockito code and just Hamcrest assertions, because it's all Java, right? It's all there's really yeah, there is some magic with the Mockito objects, but it plays nicely with just plain old Java stuff. Um, Another thing we want to assert here is that that the request was successful. That 200 is the response code. And now we could just use the same thing up here that we did up here. We could just say, hey, verify that set status was set on response with a value of 200 with the SCOK over here. But I'm going to show off another feature of the Mockito API, which is pretty cool. It's something called an argument captor. So, the idea here is that when a method is invoked, you may want to, well, capture the value that was sent to that method, sent to that mock method, so that you can then interrogate it further, do additional assertions on it, verify that the object that was called is what you expect. And you can also do the same thing for primitives like integers. So here's what we're going to do. We're going to capture the integer that was written to the set status method. And here's the syntax for doing that. You use the verify method again. You're going to say that we're going to verify that yes, the response object had its set status method called. And instead of just setting in a particular constant, we are going to capture, we're going to use something called this argument captor, which say argument captor.for class, and then there's your integer class. Then we're going to capture that into the object, and then we can call get value on the argument captor. Just use a plain old Hamcrest assertion to make sure that is equal to 200. This code right here does exactly the same thing as this code up here, but there are times where an argument captor makes a lot more sense, especially if you have like a complex object. If you need to assert multiple fields on an object or some multiple, but anyway, you'll want to use that instead. So you can use an argument captor here. And then also, we've so basically we did the HTTP post, which posts a word and a definition to the servlet. We verified that it returned the right response. But as you may recall, the servlet has this dictionary map of strings and strings. Right? This is the data that is stored in the servlet. And we also, as part of the unit test, want to make sure that the data is stored correctly. The data, made it through to that dictionary correctly. And so then what we do is we call the get definition method on the servlet. So this isn't like something that's, this isn't inherited from the superclass. This isn't like doPost or doGet. This is just a method that we have here. And actually, it's nice and visible for testing so that we know that's primarily for testing, which will go and look up a word in the dictionary. And so that's convenient. We want to then assert that when we get the definition for the word from the servlet itself, right, that it is what we expect, that it does equal to definition. So we're going to run this. That's going to work too. Now, I think it's valid for you to say, wow, that's a lot of testing, right? I mean, really, we call one method, we've got a bunch of assertions, we've got all this setup and everything like that. It seems like a lot of testing. And you're right, I guess, probably compared to like the unit test for your other projects, this might seem more complex. This is more complex. That's because the project is more complex. You're dealing with this with the servlet API. You're working with objects that aren't instantiated directly from a main program like projects 1 through 4 have been. Uh, the project is different. The project's more complex, and so then the unit tests are. But you still get to unit test them, and I think that's the most important thing that you're then able to verify that the code works the way that you expect. Otherwise, you end up with a bunch of servlet code and you don't know how to test it. And how do you, if you can't test it, how do you really know that it's right? So, this is how you can use the Mockito API to allow your relatively complex servlet code to be tested. So what we're going to do tomorrow is refactor a bunch of things. We'll be, changing the names of the parameters. We will, probably be, we'll definitely be writing different text back to the print writer. We'll probably be adding some more unit tests as we evolve the code to be more like a phone bill. So I think that's what I wanted to say for the unit test for the phone bill servlet. A sip of water here. So that's how you can test the stuff that happens on the server side. Oh, and of course, by the way, your phone bill server will also use your phone bill and your phone call class and your text dumper and I guess it won't use the text parser, it'll use the text dumper. And so you can still have, you can bring over the unit tests for all of that code as well, which you should. They'll verify that it's still working in case for whatever reason you need to change your text dumper. And of course, it'll also, help you get the required code coverage. Now let's turn our attention to what's happening over on the client side. I was showing the web client before, this web page that we've got. We can list all of our entries here. We have test word, and we have doe, deer, female, deer. But the way I'm going to use the command line uh, program to test your code. So that's going to be what java-jar target phone bill client, yeah, client dot jar. Oh, weird. Why was it printed twice? No, I guess it probably prints it on an error too. Anyway, the host is going to be localhost. The port is going to be 8080. If I don't specify any other parameters, then it'll print out, yep, the contents of the dictionary, which basically makes the same call that we made here in the browser, right? It calls this URL right here, behind the scenes. And similarly, if we want to have let's see here. What do we say? We say word equals doe here. Here's Prince doe, deer, female, deer. We can make that same call by giving it the doe parameter. Now, the way this client program works is that that's nice. Um, the way this client program works is that it's got a main class called Project 4, and then it uses this phone bill REST client class to interact with the servlet. And the purpose of the phone bill REST client is that it gives you like a nice API around these HTTP GET calls. So, as you may recall from the web lecture, Java has APIs for working with URLs, and they're kind of generic and low level, which is fine, right? You need to have something that is generic for working with any type of URL. But in your program, you want to deal with higher level concepts like adding phone bills to a phone, sorry, adding phone calls to a phone bill, and printing an entire phone bill, things like that, querying to find all the calls that begin between two times. Oh, sleepy. Sorry. Um, and so then I want to spend some time walking through the phone bill REST client class, how it works, and how these abstractions separate the code so that your project 4 doesn't really need to worry too much about the fact that what's being invoked is a REST API. It can deal with higher level concepts like the phone bill and phone call classes that you're used to. Oh, and we're also going to see how all this can be tested too, because phone bill REST client is another class that ought to be unit tested because it does have a goodly amount of application logic in it. So let's look at our phone bill REST client. Okay. So again, this is on the client side. So this is the code that will ultimately invoke the HTTP. Oh, well, sorry. This is the code that will make the HTTP request, which is then fulfilled by the servlet. Again, lots of moving parts in this program. So what does this program need to know? Well, it needs to know what the URL is. So it needs to know its web app. It needs to know its servlets. And then it uses this class called HTTP request helper, which is a class that I wrote. It's often my example code. And the whole idea here is that HTTP request helper is meant to take care of all of the stuff required to make the low level URL request. Um, I hope this is helpful that yeah, you can read about the API or you can watch the lecture on the URL API. But ultimately, it's kind of low level, and I thought it would be, easier for you all if I, wrap some of that in what I think is an easier to use API. I'll let you be the judge. I'm curious about what your experiences are there. So a phone bill REST client uses an HTTP request helper object to get its work done. And so we've got a dependency between these two objects. And so then the phone bill REST API, the REST client delegates a goodly amount of responsibility off to the HTTP request helper. And actually, I'm just going to look at HTTP request helper um, right now. Basically, what you do is you give it a URL, and it gives you a Java API for performing a get on that URL. And what you do is you pass in a bunch of the key value pairs, which would be the key value pairs that are on the on the URL. So basically, the query part of the URL, those key value pairs get passed into the get method via a map of strings. And then again, this is the my helper code. This is responsible for making sure they're properly encoded, making sure that the URL string is put together correctly, and then it creates this response object that is a response from that URL. And again, this prevents you from having to use these low-level Java classes like java.net.url and then HTTP URL connection. There's a similar method for post that takes care of putting together the body of the post and then doing all of it. So this is just code you could read over if you want, or you can just you know use it. The response class, so this is what's returned by these methods. The response has information like, hey, what was the HTTP status code that came back with the response? And then also what was the content of the response? And then how many lines there were. So it takes care of reading everything from the input stream and handling the HTTP status codes, all this good stuff, so that you don't have to. Oh, nice. It's got a little main method. Didn't realize it had that. Well, that's cool. Oh, and it's also got this REST exception. So this is an important one. Uh, the code that uses the HTTP request helper is meant to provide fluent Java APIs over whatever it is that you are whatever REST API that you are invoking. And so then when something unexpected happens with a fluent Java API, an exception is thrown. And so then, this code throws a REST exception. Let's see here where do we find that code? Um, well, let's see. I'm sure get would throw an exception. Oh, maybe it's the response. Oops, come on. There we go. In the response. Oh, interesting. Where is REST exception? So like, where is this guy used? Oh, I guess it's only used here. Okay, so I guess it's up to the client then to throw the REST exception with the appropriate, status code based on the response, and then whatever message that you want, whatever application specific, message you want to include with that. Okay. That's neat. Yeah, let's take a look at how that's actually used. So this is the HTTP REST client. Sorry, the HTTP request helper. This is code from my examples library that I encourage you to use in your REST client. So what do we do in the phone bill REST client? Well, you can create it giving a given host and a port, and it'll always and it basically then initializes the HTTP request helper with the URL that is formed from the host name and the port, and then the phone bill and the phone calls, um, your web app and the servlet. But there's also a variation. There's another constructor where you can pass in your own HTTP request helper. And we'll see that can be used with unit tests by passing in a mock HTTP request helper that you can then program to behave, a certain way. And that way, this code, the phone bill REST client can be tested outside of it can be tested without having to have a real servlet running inside a container responding to real HTTP requests. I'm just going to actually, maybe at this point, instead of just walking through all this code, let's just take a look at the unit tests for this. So I said this class can be unit tested. So let's go look at that. So let's look at the phone bill REST client test. Okay. So remember, this is testing the client side. So all we're doing is, unit testing stuff that happens over here. And we're going to unit test it in a way that doesn't require a real HTTP request. So the first unit test here is get all dictionary entries performs HTTP get with no parameters. So basically what we're testing here is that when you ask for all of the dictionary entries, the URL that is requested. Let's just go do that in the real world here. When we ask for all dictionary entries, the URL is requested has no parameters. So it's just this. It's just the slash phone bill slash calls. There is nothing after the question mark. And so let's validate that, right? And what that tests is that the phone bill REST client assembles the URL correctly, and that's important. That's its job, right? What its job is to put together the URL and then handle the response appropriately. So what we're going to do is the following. We are going to right. We are going to we're going to put together like a test dictionary that has two words. The word is one, its definition is the number one. The other word is two, its definition is the number two. Maybe not the best test data in the world now that I look at it. But anyway, that's there in our dictionary. And we want to have an HTTP request helper that when the get method is called, it returns that dictionary. So let's figure out how to do that using the Mockito API. What we want again is an HTTP request helper that when its get method is invoked with no parameters, then the entire contents of that dictionary is returned. So ultimately, what we want to do is the following. We want to say, hey, listen, I want to create a phone bill REST client, and when all of its entries are returned, then that dictionary is returned. And note, get all dictionary entries returns a map of strings. That's why the test data here is a map of string to string. In order to get this to work without an actual servlet running that has been populated with this data, we need to mock out the behavior of the REST API. So what we're going to do is basically create ourselves an HTTP request helper such that, well, when its get method is invoked with zero parameters, then it's going to return that dictionary entry. And here's how we do that. So we create a mock HTTP request helper, and we say, listen, the get method of our mock HTTP request helper is invoked with an empty map. And so this right here is the parameter to the get method, which is a map of strings. And we use this method from Mockito, which is It's kind of like a matcher, but yeah, it's kind of like a matcher called EQ. So it's basically when it's when the objects are equal. Boy, I can't remember off the top of my head right now, but like Mockito often requires that you use like the EQ method to say, hey, when the value of this parameter equals some other parameter, in this case, an empty map. So when get is invoked with an empty map, then return, well, what the get method returns is this response class. So we're going to use this method called dictionaries text, which is down there, to return a response that contains this dictionary. Or actually, it returns a response created from this dictionary. And so here is just a little test method that takes a dictionary, a map of string to strings, and returns one of these responses. And what's important here is that the content of the response is the text format is the text format of the dictionary. So this is kind of a wacky thing that we're doing here, but what do we do? Well, we create a text dumper. So there's a text dumper that comes out of the box with the application. Actually, one of the things we'll refactor tomorrow night is turn this into a text dumper that takes a phone bill instead of just it dumps a phone bill instead of just dumping a map of strings. But we just use our text dumper to then dump the contents of that dictionary that was passed in here to a string writer. And so then this guy takes a writer. The constructor to the text dumper takes a writer, which should be familiar to you from your projects. And what this will do is this will dump the dictionary to that string writer, and then we'll just create a new response with whose content is that string that was written. This is basically simulating something that would happen in the servlet. It streamlines things because it's just for test data and stuff. But that's basically what we're running. And then this is the sort of the both the beauty and the challenge of this testing with mocks is that it's you are often you're invoking the code that is under test. You are invoking the real code, but you then kind of have to do a little bit of acrobatics, a little bit of stretching in places in order for the context in order for your code under test to be executed in the appropriate context. So that's a lot, right? But it's a couple lines of code, but it does a lot of things. So what you're doing, once again, is you are programming your mock HTTP request helper to say, hey, listen, when its get method is invoked with an empty map, then return the entire contents of the dictionary. But once you've got one of those, then you pass it to your codes under test. So you create your phone bill REST client with that mock HTTP object. It doesn't know that it's mock. It doesn't care. And then when you call the get all dictionary entries method, it should return the a response. It should return the contents of that dictionary. And let's take a look at this code that's under test here. So what does it do? Well, in order to get all the dictionary entries, what you do is you invoke the URL. You do a get of the URL with 0 parameters. So it's the thing that calls the get method with an empty map on the HTTP helper that was passed in. And recall in your unit test, the HTTP helper is a mock object. But this code doesn't know. This code doesn't care. So it goes and does that and gets a response. Now, in the real code, it would call, or rather, when it's running for real, like when we ran it from the command line here, as we want, let's see here, we want all responses, so there's no objects. So when we do that here from the command line, then it actually invokes, the real servlet over here, and and prints out all the stuff in our unit test. And so that's the code that happens right here. So this code is ultimately invoked on the left side there by the command line program to get all the dictionary entries. So it goes off and calls the REST API, and then it takes then it says throw exception if not okay status not okay HTTP status, which is this method down here. It takes this response object. Remember that response comes from the HTTP request helper method or class, HTTP request helper class. And it says, great, I'm going to get its response code. And if the response code is not HTTP okay, I'm going to create a new REST exception. And that's nice, right? So that way, if something goes wrong or something unexpected happens, then you get an exception thrown. Otherwise, if the request did come back as a 200, if everything was happy, then what are you going to do? Well, I'm going to get the content that was that was returned by the HTTP request. So in this case, it'll be the text format of all of the dictionary entries, because that's what that's actually what is set here. The text format has a colon. We'll refactor all of this to be phone bills, so I think it'll make a lot more sense tomorrow. So it gets that text there, and now it's going to use the text parser to turn that into, well, ultimately what is parsed here, which is a map of string to strings. Tomorrow we'll refactor that to be a phone bill. So, this is like this is a pretty simple method. These four lines are using a lot of pieces of code, right? It's using actually, a lot of other classes. So then it's using the HTTP request helper here. It's using the text parser, and of course then it's using standard APIs like string reader to ultimately get the result of the parsed text, which is a map of string to strings. And all of this can be tested in a unit test. That's what this does right here. So that's calling the get dictionary entries, and you want to make sure that and we want to assert that what's actually returned is that dictionary that we expect it to be returned. And what all this other stuff is doing is basically, simulating what the servlet does in terms of shuffling the data back and forth using the text format. And so when you run this, yeah, it runs. And so this is really powerful, right? You can unit test this phone bill REST client, which has a lot of, functionality. It has the ability to get all the dictionary entries. You can get a definition from it. And here again, tomorrow we might, write some unit tests for all of that. But all this can be tested thanks to Mockito. So that was unit testing. Um, You can unit test your phone bill on the server side. Sorry, your phone bill servlet on the server side. You can or unit test your phone bill client for the client side. And they are true unit tests, right? They run really quickly. Uh, they don't require that a servlet be running, right? So I can just kill my servlet right now, not running, but then we can still verify that yes, this code runs completely independently. Oh, we can go find the test and have it run completely independently of the other code. And the same thing with the phone. Sorry, completely independently of your servlet. Let's do the entire class this time. Nice and fast. However, so unit tests are great. However, we still want to be able to test the end-to-end interaction of the entire application, right? Wouldn't it be nice for us to, make sure the servlet behaves when it's run inside Jetty and that the code for handling, real actual REST API results in the phone bill client and in the Project 4 client behave as expected? Well, you can. Basically what and you do this not through unit tests, but through integration tests, right? We've been working with integration tests for almost the entire course now. And, you remember that an integration test is more complex. It works with the integration of multiple units, multiple modules within your program. And so then, wouldn't it be cool to be able to take the phone bill REST client code and test it against a real running servlet to make sure that, yeah, the data is actually passed back by Jetty, is formatted correctly and encoded correctly, all that stuff works? The answer is yes, you can, as long as there is a container running. So there are integration tests. So like there's this phone bill REST client integration test. ITs. This is all in the IT directory. And what this thing does is it creates a phone bill REST client and not with a mock HTTP request helper, but the actual one. So it invokes the two argument constructor that creates a real HTTP request helper and then interacts with it. Now, this is interesting because with the unit test, the servlet is created each time, or the mock servlet or the mock HTTP request helper is created each time. It's very ephemeral data. But when you're running an integration test, you want to launch the web container once and then have multiple requests made of it. So there's going to be persistent data, and you need to be mindful of the order of operations the order in which operations are performed. So, basically, I want to make sure that the methods in my test are always run in in a particular order, and that the first one, clears out any data that might already be there. Because, you can run and actually, I'll just do that now. Um, well, first I'll run all of these integration tests with no tests with no servlet running, and not surprisingly, they all fail because the connection was refused. Right? These tests are attempting to call to make HTTP calls. So this is the REST client. It's trying to make calls here, and the server isn't running, so all of that fails. Not terribly surprising. But once I start it back up again, and do recall that when it restarts, you lose all of your dictionary entries. So there's no dictionary entries in there now. But now when I run my tests again, well, everybody passes because um, there's actually a servlet running. And oh, as you can see, there was some stuff that was called. And if we go back to the web browser and we reload this URL, okay, now it's got some test data in it. Okay, neat. And it's pretty much what we expected. So that's how the integration tests work, right? So the integration tests require a running Jetty. And let's see what this does. So, and again, this uses the phone bill REST client. And oh, note that I've got this test method order method name dot class annotation on the class. And this is a JUnit 5. I think it's JUnit 5, right? Yeah, yeah, yeah. It's a JUnit 5 annotation that basically says, hey, listen, when all the methods, well, when this test is run, invoke the methods in alphabetical lexicographical order by name. So basically, sort them by name and then run them in that order. And that's why I have test zero, test one, test two, I guess there is no test three, goes on to test four. That way, I can guarantee that they're all invoked in the same order. If you go back to the JUnit lecture, there are other ways of doing that. I don't know. This is what I chose to do here. So the first method is here for testing, and what it does is it clears out anything that's already in the dictionary. Because, as we just saw, there's like leftover test data, and I can, put more stuff in. Um, I can put in, doe, a deer, a female deer. Oops. I can put in, here we go, doe. And I think the solfege doe is just do, isn't it? Anyway. Right? It's got this in there now, and then if I do the get, it's got both of them. And before I run my test, though, I want to have a clean environment so that there isn't like leftover data that confuses the test. And so the first thing I do is I use this phone bill REST client to call this remove all dictionary entries method. And what this does in turn is it calls a delete on the delete. It invokes it calls it invokes the URL, the phone calls URL, the calls URL with the delete verb. And we actually didn't talk about this in the servlet, but if we go back to the servlet, there is oops, so I always get that wrong. There is a do delete method, which basically just clears everything that's in this in-memory dictionary. This is there for testing. It's not, it's not something you want a real application. You don't want to make it this easy to delete all your data, but it does make it a lot easier to test. So, oh yeah, that's what the first method in the REST client integration test does is deletes everything, and then it just uses the REST API. So, here is one that says, great, you've got an empty server. It doesn't contain any dictionary entries. So what do we do? Well, we create ourselves the REST client. So there's just a little helper method that will create the REST client, and it takes into account the fact that we can configure the host name and port, like if we want to for the tests. Um, and so it gets you a new client, and then it says, hey, give me all the dictionary entries, expecting that because it's the second test to be run, there isn't any data there. It'll get you a dictionary object, and we can say, great, I expect the size of the dictionary that's stored, I fetched from the server to have a size of 0. And this all goes through the REST client. Here's another example of using the REST client, which defines one word. So we're just going to create a new phone bill REST client. And we're going to have our test word and test definition. We're going to call the add dictionary entry method, which in turn does an HTTP post with the word of this and the definition of that, and it'll complain if it doesn't get a 200, but otherwise it just does its thing. And so then here we are, we're going to add the dictionary entry, and then we use the client to get the definition of a particular word and assert that is what we expect. And for me, this demonstrates the value and the purpose of having this REST client. The REST client speaks in the language of a dictionary. It is the domain language for our project. And what we'll do tomorrow night is we'll refactor this to be a phone bill with phone calls and stuff like that. So you'll have add phone call instead of add dictionary entry, and you'll pass in a phone call object instead of the domain types for the dictionary, which are strings. So it adds a dictionary and then calls get definition. And then you give it you give it the word and it returns the definition. And then you use a plain old a ham crest assert to make sure you get the definition that you expect. So yeah, again, this uses this is a Fluent API on top of your REST API. Fluent Java API on top of your REST API. The fourth test is actually, well, it's test number four. It's like only the third test. Is verifies that when you attempt to invoke the add dictionary entry, no, sorry, oh yeah, sorry, when you attempt to define an empty and well, when you attempt to make a definition, sorry, when you attempt to put in a dictionary definition for the empty string, that you get a REST exception. With the whatever this is, precondition failed, we'll get 412 here. And this basically demonstrates that the REST API client handles a non-200 response appropriately. But it does it with Java stuff, and it does it with JUnit 5 things like assert throws. So here we have an empty string. And if we try to add an entry to the dictionary that gives it, empty strings, then what we should get back is a REST exception. That's what should be thrown. If it isn't thrown, then the test will fail. But we can capture the REST exception and then interrogate it and say, great, I expect that the REST exception that was thrown by calling add dictionary entry with empty strings has a status code of 412 and has a message that contains this missing required parameter method. Sorry, the string returned by invoking this missing parameter required method from this messages class. And oh yeah, right. The messages class. This is something that I added in there because it makes the dictionary easier to test. You probably, I don't know if you'll need this or not. Um, it might just be that between like your text dumper and stuff that it'll that you may not need this. So if you find yourself not using these methods or wanting to delete them, that's perfectly fine, perfectly okay. So, oops, sorry, I want the integration test. There you go. The integration test here. And so then you can run all this again and it'll pass because it interacted with the servlet. So that is the phone bill REST clients. And I think one more thing I want to check out is the integration test for Project 5 itself. This is the Project 5 main program. So, recall that Project 5 here has a main. It's the code that's invoked over here on the client side. Out of the box is a pretty simple thing, although you guys should be really good at writing main methods by now. So then I'm not going to show you how to refactor it or anything like that. Um, and you can test this. So the Project 5 uh, class is the thing that ultimately uses the phone bill REST client that you create with the host name port that are passed in on the command line. Oh, sorry, the host and port that are passed in the command line. And it interacts with it based on the other command line arguments. So like when no word is provided, then right there are no parameters, which is the case here. We just have localhost and port. Then it'll use the phone bill REST client to get all the dictionary entries, and then it'll use the pretty printer to format those to standard output. Similarly, you can call get definition for a particular word, or then you can then call add dictionary to put the word in the definition in. And here again, this is another example of having separation of responsibilities. Your main, you because you put all of the responsibilities for interacting with the results of or processing the results of the REST API calls into the phone bill REST client, then your main method, you can just deal with that. It doesn't really know that there are HTTP methods, there are HTTP, HTTP requests being made behind the scenes. It doesn't need to be that smart because this could be really complicated otherwise, right? So by, encapsulating the behavior related to working with the HTTP request helper to make the HTTP request calls, and then taking the text that's returned from the web server and then converting it into objects like maps of strings um, to provide a fluent API makes this code the sort of the client of the client code much more straightforward. And we can have an integration test for this. And because it's the main method, we can just use our old friend invoke main test case, right? And so that's what this all this does. Um, It uses, invoke main here with like no command line arguments to make sure that it's got, the right error message. Let's do something a little bit more interesting. Oh, here when you invoke the yeah, when you invoke the main program, when you run main with only a host name and a port, and there hasn't been any dictionary entries created, then you get, an empty string written to standard output. Oh, sorry. Nothing's written to standard error, and instead you have like a, zero word count come back. And just like other stuff. I guess this is probably the most interesting test case. So this uses the main class to add a definition. And so what do? You invoke main with, word and definition, which is the same thing as if we had, done, array and drop of golden sun. Here, we define that. We're going to do the same thing here, but with this test data with word and definition. So we're going to invoke main with, all four of the parameters, host name, port, word, and definition. Nothing's written to standard error. And what is written to standard output is, this phrase right here, define array as drop of golden sun. And then we're going to just, do some other stuff to test it out. So then we're just going to get the definition by only passing in the word, making sure that that works. And then we're going to get all of them, we're going to get all of the entries and make sure that that's there too. So the bottom line here is that, even though the code in this project is very different than the code in your first four projects, you can still test it. And therefore, I can expect you to have 75% of your code covered by tests. You can do test-driven development with this code. It's even like kind of more mind-blowing than it was in the first ones. But I think once we refactor all this code, you'll see how to approach this. Because we'll be taking a test-first approach because we want to, as we refactor it, we want to keep our tests running clean. So, we've seen a lot about testing. We saw the unit tests for the phone bill servlet and for the REST client, the phone bill REST client, and we also saw integration tests for those things. I guess the last thing I want to point out is the following. Because they are unit tests and integration tests, Maven can run them. And if you look at the pom.xml, you'll see, and maybe I can just show you. Um, if we look at the pom.xml, you'll see that in addition to all this kind of stuff, there is some specific servlet specific things here. Oh yeah, here we go. And so Maven has a plugin for Jetty. So Maven knows how to start and stop Jetty servers. And what this allows you to do is configure your Maven project so that before you run your integration tests, it'll start your Jetty and deploy the web application to it. So what this allows you to do is when you run Maven clean verify, It'll go through all of its phases. It'll develop, it'll compile the source code, it'll compile the unit tests, it'll run the unit tests, it will create the war file and the jar file. It will, and then and then it'll execute the integration tests. And in the integration tests, before it executes the integration test, well, you just kind of scroll off screen now, it starts up your container, right? We see these same messages that we saw when we just ran Jetty Run. It starts up the web container, it deploys the web application to it, and then it runs your integration tests with with the server up and running. And so your integration tests, will pass because there's an actual server for them to run with. And all this is done with Maven. And so this is all done with one command line argument. It's done as part of the continuous integration builds that happen on GitHub. And for me, this is just really cool because you can use the same techniques, the same concepts that we've been using throughout the course for writing unit tests, for writing integration tests, for having an automated build for all of this stuff, even though we are working with a REST API that requires a running Java web container. Let's see here. I think that's it. Not surprisingly, I talked for a long time. I've been known to do that. I'll do it again tomorrow night for all of you. But I really wanted to take a few minutes and refocus ourselves on Project 5, go into more of these details about the various constituent parts of the project and how they can be tested. I think it'll help us have a more effective discussion tomorrow, and then it'll also help you all get started on your Project 5. And so then I'll stop the recording now and I'll post it shortly to YouTube and make a posting about it on Slack. Um, I'll encourage you all to watch it before class tomorrow night. And I look forward to seeing you all and interacting and exploring Project 5 some more. I hope you find it compelling. I'll see you then. Bye.